Exercise 6.2 Problem 12 Discussion. A student wants to determine the height of a flagpole. He placed a small mirror on the ground so that he can see the reflection of the flagpole. The distance of the mirror from him is 0.5 meters and the distance of the flagpole from the mirror is 3 meters. If his eyes are 1.5 meters above the ground level, then find the height of the flagpole. The foot of the student, the mirror, and the foot of the flagpole lie along a straight line. It looks little complicated. Let's draw a simple diagram. So how will you draw? So that you will have a flagpole, vertical flagpole, and you have a person, and you have, let's say, I'll just draw. Okay, anyway, I'll just draw. So this is the flagpole. First you have to draw the flagpole. Then you have a person standing here. His eyes is at 1.5 meters. So, and okay, the first thing is that draw the ground. Then put one flagpole and put a person here. So it's represented by the straight lines. And the midpoint, somewhere in the midpoint, put that as the mirror point of mirror. So then join his eyes to the mirror and the top of the flagpole to that point. That's all is the figure. Okay. So now let's name it. So let AB represent the flagpole, CD represent the person. Okay. E is the point of the mirror. Okay. And we know this distance, that is the distance of the distance of the mirror from the person, from the man, is 0.5 meters, and it's given, right, the distance of the mirror from him is 0.5 meters and the distance of the flagpole from the mirror is 3 meters. So therefore the distance between the mirror and the flagpole is 3 meters. So these two are given. His eyes is 1.5 meters above the eye level, right? That's all it is. Now if you look at this, these two lines are parallel to each other, right? This is also vertical, he is also vertical, so this is perpendicular and this is perpendicular, and this light comes here, reflects at the point mirror and reaches his eyes. So this is angle of incidence and this is angle of reflection. We know as per the light, as per the laws of light, angle of reflection, angle of incidence equal to angle of reflection. Therefore angle AEB will be equal to angle DEC. Okay. Now if you see, these two angles are equal to these two angles. As per AAA criterion, if you have two angles equal, then obviously the third angle also will be equal, right? So we don't need to go into that at all. These two triangles are similar. If they are similar, then the ratio of the sides are equal. We want to find this, right? So AB by CD will be equal to BE by CE. So in that equation, only one is unknown. You'll be able to calculate it. So the key is, first you'll have to show that this is a similar triangle. Okay, so now list out all the measurements. You have drawn the diagram. We need to calculate height of the flagpole. And the formula or the hint actually is AAA similarity criteria. So you'll have to prove that these two triangles, this one and this one, are similar to each other. And the criteria which is used is AAA criteria. Okay, how will you do? First draw the figure and mark the given information as we discussed. Then show these two triangles are similar to each other. How will you show? So this is angle of incidence and this is angle of reflection. So these two angles are equal. These two are perpendicular to the ground. Therefore, these two are equal. So this is equal to this and these two are equal. Then by AAA criteria, this triangle is similar to this triangle. Once they are similar, then what we do? We use the ratios of the sides. So AB by DC will be equal to BE by CE. In this, CE is known, okay, and AB is not known. This is only one unknown, right? And CD, yes, this is also known, okay, and BE, yes, this is also known. So 1, 2, 3 is known, only 1 is unknown. So you'll be able to calculate AB. What is AB? AB is the flagpole, height of the flagpole. Okay, so what I suggest is you pause the video here and try to work this problem on your own, and on completion, please come back and check your working against our solution. Okay, now let's get into the solution. So we'll draw the diagram. Okay, so now if you look at the diagram, you'll be able to make out that, okay, this is the flagpole, this is the person, and this is the mirror, and the distance of the mirror from the person is 0.5 meters, and the distance of the flagpole from the person is 3 meters, and the level of the person's eye from the ground level is 1.5 meters. Now we know this side is parallel to this side. Both are vertical to the ground level. Am I right? So this is the ground level, right? That is BC is the ground level. So this is perpendicular to each other. And next, so which means this angle DCE will be equal to angle ABC. They are at right angle. Next, we know this is how the light travels from here. It falls onto the mirror and it reflects, right, and reaches the person's eye. So this is angle of incidence and this is angle of reflection. So angle AEB, I'm sorry, will be equal to angle DEC as per the laws of light. Now, in these two triangle DCE and triangle ABE, you have one angle. These two angles are equal, and the second pair is also equal, and two pairs of angles are equal in a triangle. As per AAA criteria, these two triangles are similar to each other. Am I right? Now, okay. Now, what happens when they are similar? The ratio of the sides will be equal. So let's apply. So AB by DC will be equal to BE by CE, the ratio of the corresponding sides. So you will have to be very careful, corresponding sides. So now we have this equation, substitute. So this will be AB, and we know CD. How much is CD? CD is 1.5 and BE is for 3 meters and CE is 0.5 meters. So substitute all those values here. This equation becomes AB by 1.5 will be equal to 3 into 0.5. This 1.5 goes to the other side. So AB will be 3 into 1.5 divided by 0.5. So 0.5 will go and 1.5 3 times. So 3 into 3 is 9. So the height of the flagpole is 9 meters. Okay. So I hope it's clear. If not, please go through this one more time. It will become clear. Thanks for watching this video.